Okay, hello finite math students. It's been a while since I made a video for your class. I think it's been a couple of weeks. Excuse me. I've been busy with my other classes and family obligations. Um, so for this particular video, I'm going to concentrate on solving two of the problems in your current homework assignment. I suspect that many of you are struggling with this assignment, but it really is an important assignment. It is an important assignment and it must be completed by November 1st. So as you can see from my calendar here, this is Tuesday, October 20th. Tuesday, October 20th. So that gives you about 11 days to finish the assignment, and it is an important assignment. So please, let's get moving on this assignment. If you're really struggling with it and can't figure it out, you need to contact me and perhaps we can do a video conference for 1 hour or something like that, and I can help you with some of the problems. I will definitely not help you with all of the problems, but I can help you with a few of them. The bottom line is, guys, this is an asynchronous online course, which means you have to learn a lot of the material on your own. I can't be there to hold your hand. You have to do a lot of the research, a lot of the studying on your own. You have to work and study independently. That's the nature of this course. Okay, I can provide some guidance, but honestly, most of it has to come from you. And, that's how online education is, especially online college education. Okay, so enough preaching for now. I think you understand what your responsibilities are. So I'm going to do two problems from the homework. Okay, one will be a word problem and the other one will not be a word problem. So this is problem 119. This is not a word problem. Okay, it's a standard linear programming problem that we're going to solve graphically rather than using matrices. We will use matrices to solve linear programming problems in the next chapter, in the next homework assignment. But in this one, we are graphing our solutions. We're graphing our solutions on the XY plane. Okay, so this is not a word problem. This is just a regular linear programming problem. The next problem that I do for you will be a word problem. Okay? Okay, so let's get going here. Solve the linear programming problem. Minimize and maximize P. P usually stands for profit, but it doesn't have to necessarily. P is equal to 15x plus 10y. Subject to these restrictions or constraints, x plus 2y has to be greater than or equal to 18. 3x plus y is less than or equal to 39. Negative 4x plus 7y is less than or equal to 48. And x and y both have to be greater than or equal to 0. And we're told that we have to minimize and maximize this function. This is called the objective function. P is equal to 15x plus 10y. Okay, so let's see what the picture is going to look like. Region plot. Okay. X plus 2y greater than or equal to 18. And 3x plus y is less than or equal to 39. And the ampersand, the double ampersand means and. It means and. Negative 4x plus 7y is less than or equal to 48. Remember, when there's a space here, the space means times. Okay, so I have x plus 2y is greater than or equal to 18. 3x plus y is less than or equal to 39, and negative 4x plus 7y is less than or equal to 48, and x has to be greater than or equal to 0, and y has to be greater than or equal to 0. Okay. And for x, now we have to think about this a little carefully. If we're looking at this equation, x plus 2y is equal to 18, we're just looking at the line rather than the entire region. If y is equal to 0, we know x goes to 18. If y is equal to 0 here, 3 times 13 is 39. If y is equal to 0 here, well, negative 4 times negative 12 is going to be positive 48. So it looks like x, the largest x value, is going to be 18. Let's go up to 18. Now for the y range, if x is equal to 0 here, 2 times 9 is 18. If x is equal to 0 here, y is 39. If x is equal to 0 here, y is going to be 7 times what is 48. 7 times 7 is 40, about 7. About 7. So it looks like y should go up to 39 if we want to see the entire picture. Okay, so that's my feasible region, although the picture could be a little bit better. The picture could be a little bit better, right? So this is my feasible region. This is my feasible region. Okay, so the boundary style. Excuse me, I have a terribly sore throat today. Let's make that a nice thick line, and let's make it black. Okay, that looks good. And these tick marks could certainly be a little bit bigger. They could be a little bit bigger. So we're going to do frame tick style, directive, font size is 18, font weight is bold, font color is black, and font family, I happen to like Roman. Okay, that's okay. We can make this picture a little bit bigger. Image size is, let's say 600 pixels. It's a nice big picture. Okay, and we could change some other things. We could do plot style could be pink. Oops. Okay, 1 second. We could do pink, or we could do blue, whatever color you like. We could do yellow. Yellow. Okay. But the problem is here, I want to see those lines. I see the feasible region. This is my feasible region right here, but I don't see the lines. I don't see the lines. I would like to see the lines. So in order to do that, I need to plot these lines. Now, when you're plotting the lines, you're only going to plot the independent variable, which is usually going to be the x variable. So for here, for example, you would have 2y is equal to 18 minus x. So you're going to have 18 minus x divided by 2. You're going to have 18 minus x divided by 2. Okay, 18 minus x divided by 2. And x is going to go from 0 to 18. Don't worry about the y values. That's automatically figured out for you. And then the plot style will be absolute thickness 5 black. And if you're combining 2 or more pictures, you need to use the show command. Show. Okay, so there we have, you know, one of the lines. There are 2 other lines we have to graph. Okay, so plot. Now we have 3x plus y is equal to 39. So 39 minus 3x. X goes from 0 to 39. Oh, 0 to 18, I should say. Sorry. 0 to 18. And the plot style should be consistent. So let's make it thick and black. Oh, hold on one second. Sorry about that. We need a comma here. Okay, why did... There we go. Okay, this is starting to look like abstract art at the Field Museum, right? Okay, so that looks pretty good. And then we have one more line that we're supposed to, well, not at the Field Museum. This looks like abstract art at the Art Institute of Chicago. But this graph tells a lot. It tells us quite a bit. Okay, so we need to graph one more line. That's this line over here. And let's see, plot. So we have the line negative 4x plus 7y is equal to 48. So that's going to be 48 plus 4x divided by 7. Again, x will go from 0 to 18. Plot style, absolute thickness, and black. Okay. Excuse me. So that looks pretty good. And we can see from the graph that there are 3 corner points. There are 3 corner points. Okay, you have a point here, you have a point here, you have a point here. Now, to make this a little bit easier to see, we could change the colors of our lines. So this line could be blue, this line could be red, and this line could be green. Okay, so now we can see these lines a little bit better. We can see the intersection points a little bit better. So the feasible region here has 3 corner points. There's a corner point right over here where the red and the green lines intersect. There's a corner point here where the blue and the green lines intersect. And there's a corner point here where the red and the blue lines intersect. Okay, so we have 3 intersections. We have 3 intersections, and as you can see, and this is the command in Mathematica that you would use to generate this picture. So let's figure this out. My red line is equal to, the red line is equal to 39 minus 3x, right here. 39 minus 3x, okay? The green line is equal to 48 plus 4x divided by 7. 48 plus 4x divided by 7. And then the blue line is equal to 18 minus x divided by 2. 18 minus x divided by 2. Solve. When is the red line equal to the green line? I'm looking for the value of x. So x is equal to 9. When is the red line equal to the green line? When x is equal to 9. Okay, that's going to be this point right over here. That's going to be this point right over here. So red line or green line, it doesn't matter. Red line when x is 9, 12, or I could use the green line, same thing. Oops, sorry, 9. Same thing. So corner point 1 is going to be 9, 12. Okay, what about the blue line and the green line? What about the blue line and the green line? Solve. Blue line is equal to green line, x, flatten. X is equal to 2. Blue line, it doesn't matter whether we use the blue line or the green line for this, because at the intersection of x is equal to 2, the y value will be the same. So x is equal to 2. So corner point 2 is equal to 2, 8. And then finally, solve. Let's see, what's the intersection of the red line and the blue line, which is this point? Okay, so blue line and red line. X is going to be equal to 12. So red line 12. 12, 3. So corner point 3 is equal to 12, 3. So these are the 3 corner points. These are the 3 corner points. Okay, these are the 3 corner points. So I have corner point 1, corner point 2, and corner point 3. And these are my 3 corner points. These are my 3 corner points. So right over here, let's see. So this is going to be the point 9. Well, wait a second, that's pretty big. Hold on one second. Let me make that a little smaller. Let me make that a lot, wait a minute. Let me make that a lot smaller. Okay. So this is the corner point 9, 12. Okay, that's this point right over here. And then this corner point is 2, 8. Okay. And then this corner point right over here, this is 12. X is 12, Y is 3. So we have 3 corner points here. We have 3 corner points here. We have a corner point here, x is equal to 2, y is equal to 8. We have a corner point here, x is equal to 9, y is equal to 12. And we have a corner point here, x is equal to 12, y is equal to 3. Okay. So Now what we have to do, let me just erase this. What we have to do now is figure out what is the minimum value of the objective function p. Select the correct choice below, and if necessary, fill in the answer box to complete your choice. Okay. Well, we have 3 different points. We have corner point 1, corner point 2, corner point 3. Now, what is our objective function? Our objective function is p. Well, you know what I'm going to do? I'm going to define it like this. P of x and y. I'm defining my function p like this. I'm defining my function p like this so that it will accept a list. So p of x and y is equal to 15 times x plus 10 times y. 15 times x plus 10 times y. So what is p of corner point 1? 255. What is p of corner point 2? 110. What is p of corner point 3? 210. So which corner point gives me the minimum value? The minimum value of p is obviously 110. That is correct. What are the coordinates of the corner point where the minimum value of p occurs? Well, the coordinates will have to be 2, 8. That is correct. What is the maximum value of p? Select the correct choice below, and if necessary, fill in the answer box to complete your choice. Well, the maximum obviously occurs here at corner point 1 when the maximum value of p is 255. 255. And the coordinates, okay, that maximum occurs at corner point 1, and we can see from Mathematica that those coordinates are, let's see, 9, 12. And that's it. It's that simple. Okay, so what I'm going to do, guys, I do have a little bit of a sore throat, so I'm going to get some rest, and then later on I will make a video that will show you how to solve a linear programming word problem. So this is the problem that we just did, problem 119. It's a typical linear programming problem from this chapter, but it's not a story problem or a word problem. So I'm going to get some rest because I do have a terribly sore throat right now. And later on today, I will make another video that will explain to you how to solve a word problem or a story problem from this section. It's very similar to this, but there's an extra step. You actually have to convert the word problem or the story problem into this type of problem right over here. So there is that additional step. And then the rest is exactly like what we did here. It's exactly like what we did here. Now, I realize that some of you may think, oh, Mathematica is so hard. But when you're taking a class like this, you can be sure you're going to be using some type of computer software. It could be Excel, Microsoft Excel. It could be MATLAB. It could be Maple. It could be Mathematica. It could be R. It could be Python. It could be, whatever it is. But when you're learning computer software, the bottom line is you have to spend time with it. You have to spend time with it because otherwise you're not going to learn how to effectively use the tool. Calculators, in my opinion, are fine for high school. I do not believe they are fine for college. Calculators have their place. I think they are perfect. You know, they're fine for elementary school. They're fine. They're fine for high school. But I think by the time you reach college and beyond, you really need to start learning more about real computer software. Okay? So I will do another video later and I will explain how to do a word problem. I would love to do it now, guys, but I'm running out of steam. I do have a sore throat and I do need to get some rest. Okay, so that's it for now, and we will communicate very soon. Remember, please, if you're having serious difficulties with the homework, you need to actually contact me, and maybe we can set up a video conference. And, during our conference, using Big Blue Button in D2L, in Oakton's D2L, we can, I can coach you through a few problems. I'm not going to do all of the homework for you. That's just not going to work. But I can help you with certain problems that are especially difficult for you. But you need to reach out and ask for my help. If you're not going to email me and ask for help, then there's absolutely nothing I can do for you, right? Okay, that's it for now, guys. Take care and be well.